We need to find the value of the positive integer n for which this equation has solutions alpha and alpha plus 1 for some alpha. So already the solutions of this given equation is given to us, that is alpha and alpha plus 1. We need to find the value for this n, right? Okay, so this is the given equation for which the solutions are x equal to alpha and alpha plus 1. Let's consider this part first. So this is x square plus xi. Please note that this is not iota, this is simply a variable I, right? Then is plus xi plus I square minus x minus I. So this is 2xi, and then this is further equal to x square plus collecting the coefficient of x. This is 2i minus 1 into x plus I square minus I, right? Now let's take the summation on both the sides. This is from I equal to 1 to n, and this is summation I equal to 1 to n, separating the terms, right? So this is equal to, alright, the summation is on I, there is no I over here, so this is x square into n, or I'm simply writing nx square plus taking x outside, and then the summation is on 2i minus 1. Please notice here. So this is equal to summation on 2i minus summation on 1. So this is 2 into summation on I, that is the sum of the natural numbers, minus summation on 1, that is n. So this is equal to, okay, what is the sum of the natural numbers? It is n into n plus 1 divided by 2 minus n. So this cancelled out and we get n square plus n minus n. So that gives us n square. So that gives us n square. So this is n square or n square x. Next, the summation is on I square, that is, what is the sum of the squares of the natural numbers? It is n into n plus 1 into 2n plus 1 divided by 6, minus the summation is on I, that is the sum of the natural numbers, that is n into n plus 1 divided by 2, right? Simplifying this further, we get nx square plus n square x plus, let's take n into n plus 1 common, and then we have 2n plus 1 divided by 6 minus 1 by 2. So when you take the LCM, what do you get? In the denominator 6 and in the numerator 2n plus 1 minus 3, that is 2n minus 2, or it is 2 into n minus 1 divided by 6. Cancelling this, we get n minus 1 divided by 3. So this is nx square plus n square x plus n into n square minus 1 divided by 3. N plus 1 into n minus 1 is n square minus 1. Now we are given that this left hand side is equal to 10n. So the right hand side is equal to 10n. That is nx square plus n square x plus 1 by 3 n into n square minus 1 is equal to 10n. So this further implies cancelling n from both the sides, we get x square plus nx plus 1 by 3 into n square minus 1 equals to 10, right? Or it can also be written as x square plus nx plus, this is n square by 3 minus 1 by 3 minus 10 equal to 0. This is minus 31 by 3. And let me write this as n square minus 31 divided by 3. Now it is also given to us that the solution of this equation is x equal to alpha and alpha plus 1 for some alpha, right? Now when x equal to alpha and alpha plus 1 are the solutions of this equation 1, which is a quadratic equation in x, that implies what? That implies x equal to alpha and alpha plus 1 are the roots of the quadratic equation 1. So let's write the sum of the roots. So what is the sum of the roots then? It is minus the coefficient of x divided by the coefficient of x squared, that is minus n. And sum of the roots, that is alpha plus 1 equals to minus n, right? Okay, and the product of the roots, that is the constant divided by the coefficient of x squared. So the product of the roots is n square minus 31 divided by 3, that is alpha into alpha plus 1 is equal to n square minus 31 divided by 3. Required to get the value of n now, right? So let me write both of these conditions. For the sum of the roots, we have this to be equal to minus n, and the product of the roots is equal to n square minus 31 divided by 3. Now how to get the value of n? Either you can solve these two equations and get the value of n, or there is one more way to get the value of n. Now because alpha and alpha plus 1, we are having these two as the roots, as the solutions of the equation. And I know that if I take the difference of these, I get the value as 1. Even if I square both the sides, then also I'm getting the value as 1, right? Now as a minus b whole square is equal to what? I can write this as a plus b whole square minus 4 times ab. Can I write like this? Yes? Okay. Taking the help of this formula, let's manage this also. Your a is alpha and b is alpha plus 1. So here it is a plus b whole square, that is alpha plus 1 whole square minus 4ab, minus 4 times alpha into alpha plus 1 equals to 1. Now sum of the roots is minus n. Sum of the roots is minus n. So writing here minus n whole square minus 4 times the product of the roots. The product of the roots, that is n square minus 31 divided by 3. Easy? Easy to apply the results? Yes. Continuing this to the next page. So this is n square minus 4 by 3 n square plus 124 divided by 3 equals to 1. So that is 3n square minus 4n square plus 124 equal to 3. So that is minus n square equal to, taking this to the other side, we get minus 121, or n square is equal to 121, getting the value of n to be as now 11, which is the required value for the given equation. So the value of n is equal to 11. Thank you.